Welcome to the Pro Ticker Deep Dive.
It's great to be here.
Today is, well, it's one of those days where we really have to separate the signal from the noise. And frankly, there is a lot of noise.
Huge amount.
So the scene is this. It's mid-February 2026. We are looking at AMD. And, on paper, they are just crushing it.
Absolutely. Record revenue. Their data center business is exploding. They've got massive new partnerships. Everything looks great.
But then you look at the stock chart from earlier this month, and you'd think the company just announced they were, pivoting to making toaster ovens.
It was a bloodbath.
Yeah.
I mean, what was it? 17% down in a single session.
17%. Billions in market cap, just gone, vaporized.
Yeah.
And that right there is the paradox we need to unpack today. Because normally, when a company not only beats its earnings estimates, but also promises a future of Yotta-scale computing.
The market throws a parade.
Exactly. But here, they threw a tantrum. So the big question is, why?
I think it comes down to a really fundamental shift in the psychology of the market.
Yeah.
It's a big change.
Okay.
For the last, let's say, 3 years, we have been in what I'd call the height phase of this whole AI gold rush.
Sure, promises were enough.
Promises were everything.
Yeah.
If you had a GPU roadmap on a slide and a cool logo, investors just threw money at you. Valuations were based on, dreams of what 2030 would look like.
Right.
But now we are squarely, and I mean squarely, in the execution phase.
The show-me phase.
The ultimate show-me phase. The market doesn't really care about your 5-year roadmap anymore. They care about your logistics. They care about your yield rates on 2-nanometer silicon. And specifically with AMD, they care about whether you can actually physically build the machine you promised.
So that margin for error we used to talk about, it's effectively gone to zero.
It's completely vanished. Exactly. When you are a stock that is priced for perfection, good simply isn't good enough. And what AMD delivered was a good quarter, but it came with a side of very complex, very expensive, manufacturing headaches.
Okay, so let's start with those financials, because you're right, the headline numbers were actually pretty strong.
They were.
Q4 2025 revenue hit, $10.3 billion? That's up 34% year over year.
A huge jump. And data centers just doing all the heavy lifting, as you'd expect.
But then we get to the guidance for the next quarter, for Q1 2026. And that's where the whole narrative just falls apart. They guided for $9.8 billion.
Right, a sequential decline, a drop from the previous quarter.
And that's the part that just seems so jarring. I mean, in the middle of an AI supercycle, a supposed supercycle, how do you guide down? Is demand softening? That's the immediate fear.
And that is the critical distinction we have to make. No, it's not demand. Demand is arguably infinite right now. If AMD could, magically print 1 million MI300s tomorrow, they would sell 1 million MI300s tomorrow. The issue is a combination of supply chain mix and geopolitics.
The China cliff.
We have to talk about the China cliff.
This is all about the U.S. export controls, right?
It is. If you really dig into the Q4 numbers, you see something interesting. AMD had this surprise windfall in late 2025.
A little bonus.
A big bonus. They managed to ship about $390 million worth of their MI308 chips to China. These were likely, clearing out old inventory or maybe some specific license deals that just squeezed through before the final window slammed shut.
Okay, so a quick $390 million sounds great.
It sounds great, but you have to look at the quality of that revenue. That's the key. Those MI308s. They're based on mature silicon.
So the expensive part is long over.
Exactly. The R&D was paid for years ago. The manufacturing masks are done. The yields are super high. That $390 million was almost pure profit. It just goes straight to the bottom line and props up the gross margin number that Wall Street obsesses over.
And for Q1 2026?
That window is shut. It's closed. The guidance basically drops that China revenue stream to maybe $100 million if they're lucky.
So you're losing nearly $300 million of your highest margin, easiest revenue.
You got it. And now think about what's happening at the exact same time. What is AMD doing? They're ramping up the brand new Helios platform, which is built on the 2-nanometer process.
Which is, by all accounts, the most expensive manufacturing ramp in the history of semiconductors.
Correct. So you've got this perfect storm. You are burning cash to spin up these 2-nanometer fabs with TSMC. You are paying for expedited advanced packaging, and you're losing your easy money from China all at once.
It creates a temporary but very ugly margin squeeze.
And the market looked right at that and said, wait a second. Your costs are skyrocketing, and your most profitable revenue stream just fell off a cliff we're out.
It still feels a little short-sighted, though. I mean, $300 million in the context of a company with, what, a $40 billion annual run rate? It's practically a rounding error.
In a normal market, I'd agree with you, yes.
Mm-hmm.
But in this show-me market, it's not about the absolute number. It's a signal. It's a signal of friction.
And friction is bad right now.
Investors are terrified of friction because their main point of comparison, NVIDIA, is executing like a flawless machine. There's no friction there.
Speaking of which, we need to talk about what AMD is actually building with all this expensive new tech. Because the specs on this thing, they're genuinely terrifying.
A Helios platform.
The Helios platform. Let's get into the hardware. We are talking about the new flagship chip, the Instinct MI455X.
And this is where things get, truly next generation.
It starts with the foundation, the process node, 2 nanometer.
2 nanometer, which is a massive technological leap in itself. We're talking about features that are just a few atoms wide. But the transistor count, that's the number that just blows me away.
320 billion transistors on a single chip.
Yeah. Pause on that number for a second. 320 billion. We are reaching physical densities that are, they're testing the absolute limits of atomic stability. It's hard to even comprehend.
But you're saying the transistor count isn't even the most important spec here.
I don't think it is.
No.
The real game changer, the thing that defines the whole strategy, is the memory.
432 gigabytes of HBM4.
A high bandwidth memory, Generation 4. The fastest, densest memory ever created.
So why is 432 gigabytes the magic number? I mean, looking at the competition, NVIDIA's Blackwell and now the upcoming Rubin chips, they're hovering around 288 gigs, maybe 300 depending on the specific model. Why did AMD go so incredibly heavy on memory?
It's a very specific, very strategic bet on something we call the inference pivot.
The inference pivot, explain that.
Okay, so think about the economics of AI. For the last 3 years, the entire industry has been obsessed with one thing: training models.
Building GPT-4, Gemini, Claude, all the big ones.
Exactly. And training is incredibly compute intensive. You need massive floating point operations. You need to crunch numbers for months on end. But now, for the most part, the foundational models are built. So now companies need to run them. They need to use them in their products. That is inference.
And you're saying inference is memory-bound, not compute-bound.
Completely. It's all about memory. When you send a query to a massive model that has trillions of parameters, the chip has to be able to hold that entire model in its brain, in its local memory.
If it can't, it has to go get the data from somewhere else.
Right. If the model is too big for the GPU's memory, the chip has to constantly reach out to the much slower system RAM to get the data it needs.
Which is slow.
It's agonizingly slow. It's like trying to read a book one word at a time from a library across town. It absolutely kills your latency. And it uses a massive amount of power just shuffling all that data back and forth.
The so-called von Neumann bottleneck.
Precisely. By putting a colossal 432 gigabytes of HBM4 directly on the GPU package, AMD is basically saying you can fit the entire massive next-generation model right here on the chip. No more trips to the slow memory.
Which makes inference cheaper, faster, and way more power efficient.
So they are optimizing for the running phase of AI, not just the learning phase.
Exactly. It's a bet on the future workload. But here's the catch, and it's a big one.
A very big one.
You don't just buy the chip anymore. That's not how this works. You buy the whole rack. And the Helios rack. This is where the story gets really, really complicated.
We're talking about a 7,000-pound liquid-cooled unit.
7,000 pounds. What is that? That's a Ford F-350 pickup truck sitting in a data center aisle.
It's an incredibly dense piece of infrastructure.
Yeah.
You've got 72 of those MI455X GPUs, 18 of their new Venice CPUs based on Zen 6, all integrated.
Yeah.
But here's the philosophical difference with NVIDIA.
Okay.
AMD is using the Open Compute Project standard. OCP Open Rack Wide, to be specific.
This is the classic open versus closed ecosystem debate.
Right. NVIDIA sells you the NVL72, their big rack scale system. It's a proprietary monolith. It works beautifully. It's a single unit. But what if you want to change the networking card to one from a different vendor?
You can't.
You can't. What if you want to use a different CPU down the line? You can't. You are locked into the full NVIDIA ecosystem, top to bottom, forever.
The dreaded vendor lock-in. It's every CIO's worst nightmare.
Precisely. So AMD is pitching Helios as the open alternative. They adhere to these OCP standards. This means you can, at least in theory, swap out the NICs, the network interface cards. You can integrate it into your existing standard data center plumbing.
In theory.
In theory.
Yeah.
But As we know, reality is often much messier than the pitch deck.
And this brings us directly to the rumors that started swirling around mid-February, the story that's causing all this volatility, the flyover problem.
This is, I think, the single most critical technical bottleneck facing AMD right now. It explains everything about the stock's recent behavior.
So what are the rumors?
There are reports, and they seem to be credible ones, that mass production of these Helios racks might slip from its target of late 2026 all the way into Q2 of 2027.
A 6-month delay, and the culprit isn't the brand new, incredibly complex 2-nanometer chip.
No, which is the ironic part. The silicon yields are reportedly fine. The chip works. The culprit is the cables.
Wait, the cables. Walk us through this. How could a simple cable cause a 6-month delay on a multi-billion-dollar strategic project?
It all comes down to physics. It's just brutal physics. We are trying to move data at 224 gigabits per second.
224G, that is just blindingly fast.
It's essentially the speed of light in a copper wire. At those kinds of frequencies, the standard circuit boards, the green motherboards we're all used to seeing, they become useless.
Useless how?
The material of the board, which is usually a fiberglass weave called FR4, or even higher grade stuff like Megtron, it acts like a sponge at these frequencies. It just absorbs the high-frequency signal.
So if you try to print a normal copper trace on the board to connect the GPU to the network switch,
the signal just dies. It degrades before it even gets there. We call it insertion loss and dielectric loss. The signal effectively turns into useless heat and noise after just a few inches. The motherboard itself becomes the bottleneck. The highway is too rough for the Ferrari.
Okay, so if you can't use the board, how do you fix it?
You have to take the signal off the board entirely. You use what are called flyover cables.
Flyover cable?
These are very thin, very high-quality twin-axial copper cables. They're heavily shielded. They physically plug into a connector right on the chip's substrate package and then literally fly over the motherboard directly to the port on the edge of the system.
Okay, that sounds like a pretty clever engineering workaround.
For signal integrity,
Yeah.
it's excellent. It preserves the clean 224G signal perfectly. But for manufacturing, it is an absolute nightmare.
Why?
Because you can't easily automate it. Think about it. A pick-and-place robot can put a rigid chip onto a flat board in milliseconds. It's flat, it's rigid, it's predictable, but a flexible cable.
Much harder.
A robot really struggles to grab a floppy cable, snake it through a dense forest of heat sinks and capacitors, and then plug it into a tiny fragile connector without bending it or breaking something.
And I'm assuming if you bend one of these cables too much...
You're done. If you violate what's called the bend radius, you physically change the impedance of the cable at that point. The signal hits that bend and reflects back. The data packet is lost, the link fails, the whole rack fails validation.
So they have to be installed by hand.
For now, yes. That's what the reports suggest. AMD's manufacturing partners are relying on manual human assembly for these incredibly dense cable harnesses. Just try to picture a factory floor where skilled technicians are trying to thread hundreds of these expensive, fragile cables into a 7,000-pound rack.
It must take hours per rack.
Hours. And now, contrast that with NVIDIA.
What are they doing differently?
NVIDIA saw this exact problem coming years ago. Their NVL72 architecture uses a cableless blind mate connector system.
Blind mate?
Yeah, the individual compute trays literally just slide into the chassis and snap into place.
Yeah.
Copper blocks on the tray connect directly to copper blocks on the backplane.
It's like Lego.
It's like very, very expensive high-voltage Lego. The rumor is that NVIDIA can fully assemble one of their compute trays in about 5 minutes.
5 minutes?
While AMD takes hours. And when you're trying to ship, say, 50,000 racks for a customer like Oracle or OpenAI, that difference in assembly time isn't just an annoyance. It's a fundamental scalability wall. You just can't scale.
That explains the execution risk discount on the stock perfectly. It's not that the market doubts AMD's ability to design the chip.
Not at all.
It's that they doubt their ability to build the box fast enough to meet this insane demand.
Exactly. And you have to remember, while AMD is wrestling with these cables, NVIDIA isn't just sitting around waiting. They're aggressively moving the goalposts again with their next platform.
You're a Rubin.
The Rubin platform.
Right.
And the story here is just, it's wild. I've heard the specs on this thing keep changing almost weekly.
It's unprecedented. From everything I've read, NVIDIA seems to be in a state of, I don't know, panic engineering.
That's a great way to put it. They have reportedly updated the internal specs for their main Rubin chip, the VR200, 3 separate times in the last 10 months.
And this is a reaction to AMD?
It's a direct reaction,
right.
100%. When AMD officially announced the MI455X specs with that absolutely massive memory bandwidth, the story goes that NVIDIA's leadership freaked out. Their original internal target for Rubin's memory bandwidth was around 13 terabytes per second, a huge number. But then they looked at AMD's spec sheet and saw 19.6 TBs.
And they said, we can't be second best.
They absolutely refused. So they went back to the drawing board and cranked it.
All the way up to what?
The new target is 22.2 TBs.
Wow. That is nearly a 100% increase from their original internal target. You can't just get that kind of performance boost for free. There has to be a trade-off. What did they sacrifice?
Power. Pure, raw, brute force power. They are just throwing wattage at the problem to win the benchmark.
So what's the power draw?
The Rubin chip, the VR200, is now rated for a thermal design power, a TDP of 2.3 kilowatts per chip.
3 kilowatts for one chip.
Let me just put that in perspective for you. A typical hairdryer that you might use in your bathroom is about 1.5 kilowatts.
Okay.
NVIDIA is planning to put a hairdryer and a half's worth of continuous heat output into a piece of silicon the size of a drink coaster. And remember, there are 72 of them in a single rack.
That sounds like a literal meltdown waiting to happen. How do you even cool that?
It forces a cooling war. And this is another one of those fascinating philosophical divergences between AMD and NVIDIA. It's not just about chips anymore. It's about plumbing.
We talked about the flyover cables. Now we have to talk about hoses versus bellows.
It sounds so trivial, doesn't it?
Yeah.
But this is multi-billion-dollar engineering. To cool these chips, you have to pump liquid coolant directly to a cold plate that sits right on top of the chip. AMD's solution uses flexible polymer hoses.
So like really fancy garden hoses.
Essentially, yes. Very high-grade industrial polymer. And AMD's argument for this is all about vibration.
Vibration?
Think about it. When you're pumping huge volumes of coolant at high pressure through a 7,000-pound rack, the pumps vibrate.
Right.
The fans to the radiators vibrate. Everything is shaking slightly.
Right.
Flexible hoses can absorb that energy. They act like tiny shock absorbers.
And that protects the fragile solder joints connecting the chip to the board.
Yes, exactly. The connection between the GPU and its substrate uses thousands of microscopic solder balls. If the cooling connection is too rigid, those micro vibrations can, over time, cause fatigue and crack those solder joints. The chip dies. So AMD's argument is flexible is reliable.
Okay, that makes sense. So what is NVIDIA doing?
NVIDIA uses rigid stainless steel bellows.
So no flexibility. Why would they choose a rigid connection if vibration is such a known risk?
One reason, manufacturing speed. It's the robot argument all over again.
Of course.
A robot can grab a preformed rigid steel tube and snap it into a manifold instantly and perfectly every time. A robot cannot easily grab and route a flexible hose. NVIDIA is making a calculated bet that their mechanical engineering tolerances are tight enough to handle the vibration, and they'll take that risk in exchange for being able to build racks 10 times faster.
It really is a fundamental clash of philosophies, isn't it?
Completely.
AMD is dealing what you might call a craftsman's rack. It's flexible, it's reliable, it's based on open standards, but it's really hard and slow to assemble. And NVIDIA is building a mass production rack. It's rigid, it's proprietary, it's incredibly fast to build, but it's potentially risking long-term reliability and locks customers in.
And the winner isn't necessarily the company with the highest benchmark score on a chart. It's the one who can actually ship product at scale.
Which brings us to the customers. Because despite all these manufacturing fears and rumors, the deals being signed are they're astronomical. We absolutely have to talk about India.
This was a piece of news that I think flew under the radar for the general public. But for people inside the industry, it was a massive siren going off.
This was on February 16th, 2026. AMD announced a huge partnership with TCS.
Tata Consultancy Services.
Now, normally when I hear TCS, I'm thinking, IT outsourcing, fixing code, managing corporate databases. This is not that.
No, this is not that at all. This is fundamental infrastructure building. The deal is to deploy up to 200 megawatts of Helios AI compute in India.
200 megawatts, let's just be clear, that is not a server closet. That's not even a big data center. That is a small city's worth of power.
It is a grid-scale deployment. And the key term you need to know here is sovereign AI.
We're hearing this term a lot lately, especially from governments in Europe and Asia.
And for good reason. Nations are quickly realizing that AI is the new nuclear power. It's a strategic national asset. You simply cannot rely on a foreign adversary or even a trusted foreign friend for your core intelligence infrastructure.
Right.
India does not want its national banking data, its healthcare models, and its government services all running on a Microsoft Azure server located in Virginia. They want it in Mumbai. controlled by Indian companies, running on hardware they own and understand.
So why AMD for this? Why not go with the market leader, NVIDIA?
I think it comes down to strategic alignment. NVIDIA is very, very heavily tied to the Magnificent Seven U.S. hyperscalers. Microsoft, Meta, Google. They get first priority. NVIDIA is also incredibly supply constrained.
So if you're Tata and you call up NVIDIA and say you want 50,000 GPUs...
NVIDIA might say, great, get in line behind Mark Zuckerberg. We'll see you in 2028.
Whereas AMD says, we'll take your order right now.
Correct. And maybe more importantly, AMD is giving them the blueprints. Because the Helios platform is open and based on OCP standards, Tata can actually build their own custom data centers around it. They aren't just buying a sealed black box, they're building an entire domestic industry.
And from AMD's perspective, it effectively insulates them from the U.S.-China trade war, too.
A huge hedge.
If the U.S. government decides to tighten the screws and ban even more chip exports to China, AMD now has this massive long-term growth market in India that is, for now at least, politically safe.
It's a 200-megawatt hedge. But, 200 megawatts is actually small potatoes compared to the rumor that's circulating about OpenAI.
This is the number that just stopped me in my tracks when I first saw it. The rumor is that OpenAI has signed a definitive agreement for 6 gigawatts of AMD compute.
6
gigawatts. I feel like I need to contextualize this for people. The entire national power grid of a country like Ireland is roughly 5 to 6 gigawatts at peak.
Yeah.
OpenAI isn't asking for a data center. They're asking for the entire power budget of a G7 nation.
It is a civilization-level energy request. And this is the point where the hardware discussion crashes headfirst into the brute force infrastructure reality.
Right.
You can design the chips. You can even build the racks, assuming you solve the cable problem. But where on earth do you plug in a 6-gigawatt load?
You don't just plug that into the wall. You need new power plants built specifically for this.
You need multiple nuclear reactors.
Yeah.
A standard large nuclear power plant produces maybe 1 gigawatt of continuous power. OpenAI is effectively commissioning a fleet of 6 dedicated nuclear power plants solely to run GPT-6 or GPT-7 or whatever comes next.
This just sounds almost fictional. Is this deal actually real?
The word is that the agreement is real. The timeline is the big variable. This is obviously a multi-year, maybe even a decade-long rollout. But the signal it sends is unmistakable.
What's the signal?
It signals that OpenAI is absolutely terrified of being 100% dependent on NVIDIA for their survival. They need a second source. They need price leverage. By making this massive commitment to AMD, they're firing a warning shot across NVIDIA's bow, saying, we have options.
But the pressure this puts on AMD is just immense. If that Helios rack is delayed, if those flyover cables slow down production by 6 months, OpenAI is not going to just sit around and wait.
And that is the binary risk we talked about at the top of the show. This deal acts as a floor for AMD's revenue for years to come. It's tens of billions of dollars locked in if they execute.
And if they don't?
If they miss that delivery window, OpenAI likely has clauses to breach the contract and go right back to NVIDIA, hat in hand. And AMD's stock probably goes to double digits.
It's the highest stakes poker game in corporate history.
Absolute highest. And don't forget, we also have Oracle publicly in the mix, deploying 50,000 of the MI450s, the next-gen parts. Larry Ellison is betting big on AMD's ability to deliver, too.
Okay, so just to recap, we have the chips, the MI455X, we have the rack Helios, we have the manufacturing bottleneck, the cables, we have the fierce competition, NVIDIA's Rubin, and we have the massive customers, Tata and OpenAI.
Pretty full picture.
The final piece of this whole puzzle has to be the software.
Yes, the ghost of ROCm.
For what feels like a decade, the narrative has been very simple. AMD hardware is great, but AMD software is trash. NVIDIA's CUDA platform is the unbeatable moat. Is that wall finally truly crumbling?
Crumbling might be too strong a word. I'd say eroding is probably better. And again, you have to look at it through the lens of that inference pivot we discussed.
Okay, so why does the shift to inference change the software game so much?
Because training a new AI model from scratch is an incredibly intricate, messy, hands-on process of debugging. Researchers live deep inside the code. And CUDA has 15 years of accumulated libraries, tools, and community knowledge that make that process easier.
And if you try to do that on ROCm?
If you try to train a new frontier model on ROCm, you are going to hit bugs. You're going to spend time debugging the software stack instead of doing your research. It's still painful.
But running the model for inference is different.
It's completely different. Running the model is static. Once the model is trained and finalized, you just need to execute the math. It's a much simpler, more well-defined problem. So porting a finished inference engine to run on ROCm is significantly easier than porting an entire research and training stack.
And are we seeing that happen? Is there real adoption?
There is massive adoption. RTOCM downloads are reportedly up 10x year over year. Hugging Face, which is kind of like the GitHub of the AI world, now supports AMD GPUs on day zero.
Meaning what exactly?
Meaning when a hot new open source model like Llama 4 or Qwen 2.5 drops, it runs on AMD hardware immediately. You don't have to wait months for support. That was absolutely not true 2 years ago.
But is it a seamless experience yet? Is it as smooth as NVIDIA?
No, not yet. There's still what I would call a composability challenge.
Composability, what do you mean by that?
Modern AI isn't just one single model running in isolation. It's often a mixture of experts, or MOE. You might have a vision model that identifies an object in a picture, which then talks to a language model to describe it, which then talks to a code interpreter to write a script about it.
A chain of different specialized models working together.
Exactly. And chaining all these different models together requires a very complex, very mature software orchestration layer. NVIDIA's software stack, things like Triton, they handle this beautifully. AMD's ROCm can still get pretty clunky when you try to chain too many different things together across different chips.
So if you're just doing a simple inference task like, summarize this PDF for me, AMD is probably fine now.
Absolutely fine.
But if you're building complex, multimodal, agentic workflows,
You probably still want to be on the NVIDIA platform for now. But the key is that the gap is closing. And for a huge, sophisticated customer like Tata or OpenAI, they have armies of brilliant software engineers.
they can write their own software wrappers to fix the problems.
They don't need ROCm to be perfect out of the box. They just need it to be functional. They can build on top of it.
Because the hardware savings, in terms of both cost and power, are worth the extra software headache.
Precisely. If AMD is selling you a GPU that's 30% cheaper and 20% more power efficient, a company like OpenAI will happily hire 50 more engineers to fix the software drivers. The math works out easily.
All right, let's pull back and try to look at the big picture here. We started this deep dive with a paradox. A company with record earnings and a tanking stock. We've gone through the China cliff, the 2-nanometer yields, the flyover cable nightmare, the cooling wars, and the 6-gigawatt energy crisis.
It's a lot to take in.
It is. So if you're a listener, maybe you're holding AMD stock, or maybe you're just trying to make sense of this entire industry, what is the one signal you need to watch? What's the one thing that cuts through all the noise?
Watch the Helios delivery dates. That's it. Ignore the press releases about new partnerships. Ignore the fancy benchmark charts that both companies put out. Watch the supply chain.
Be a logistician, not a technologist.
Exactly. If we start hearing credible reports in June or July that mass production of those Helios racks has started and that they are physically shipping to customers like Oracle, then AMD is a coiled spring. The stock is undervalued and the revenue is about to catch up to the hype in a big way.
And if we start hearing more rumors of yield challenges or component shortages this summer,
Then the cable problem is real, the delay to 2027 is real, and NVIDIA will eat their lunch for another full generation. It's that simple.
it really is a show me moment in the truest sense of the word.
It is. AMD has designed and built a Ferrari engine. There's no doubt about that. Now they have to prove to the world they can build the rest of the car around it without stripping the screws.
Okay, so here's a final thought for you to chew on. We spend so much of our time in this industry obsessing over the digital specs. We talk about TOPS, trillions of operations per second, and FLOPS, but we are rapidly entering an era where the primary limiting factor for artificial intelligence isn't intelligence at all.
It's not the code.
It's not the code. It's not even the silicon.
It's the physical world.
It's plumbing. It's whether a human hand can thread a tiny copper cable through a metal chassis without bending it 5 degrees too far. It's whether a polymer hose vibrates a little too much over 3 years. It's whether you can find enough concrete and copper and political will to build a new substation for a 6-gigawatt data center.
The digital revolution is slamming headfirst into analog reality.
Exactly. And the company that wins the coming Yada scale era might not be the one with the absolute fastest chip. It might be the one that solves all the boring problems first: the cooling, the cabling, the power delivery, the manufacturing automation.
Is AMD's open, flexible, craftsman-like approach the key to unlocking that scale? Or is it just too complex to build when the world is demanding 1 million units yesterday?
That is the question that will decide the next $1 trillion of market cap in this industry.
Absolutely.
Keep your eyes on the cables. Thanks for listening to the Pro Ticker Deep Dive. We'll see you next time.